Till now, what we have seen is projection of lines, and in that case, the different orientations of the lines, etc., etc., and how to draw the front view, top view, side view, etc. We have seen how to find out the true length, the true inclination with the HP and VP, etc., etc. Now, what we do is we will go through a slightly larger or a larger perspective of the objects, that is the solids, that is a visible thing. In projection of lines, it is actually difficult to imagine how an object, how this particular object, this line will look like when when you look from the front or from the top, etc., etc. But in projection of solids, obviously you can see the objects in your with your eyes, and you can easily visualize it also, because the solid is the object which occupies a space which is bounded by some surfaces, and which occupies space. And in our discussions, the uh, types of solids is limited. Actually, only the regular solids are we will be going through only regular solids, not the irregular solids. We are not bothered about the irregular solids in projection of solids. So let's first see what are the different types of solids, and what are the different classifications of solids. And this discussion is also limited to only the regular solids, which we will consider in our session, not everything, not the entire collection of solids we are not bothered about. So the solids are actually they are mainly classified into two major groups. This is again the case of basic solids. The first group is the solids having the top and bottom face, or face, or it is also known as the base. Top is known as the top face, and the bottom is known as the base or bottom face of the shape, of the same shape. So solids having top and base of the same shape is the group A. And then the second group is solids having base, some shape, and just a point as the top. That is the top is a point, and that particular point is known as the apex. So in this type of solids, the base will be having some shape, and the top will be only a single point. So let's see some of the examples. So cylinder is falling in the group A. Both the opposite faces, that is the top and base, will be of circular face, like this. It will be a circle on top and bottom. It is a circle. So it is having the same shape on top and base, and it has a third side also, that is the third surface also, which is a curved surface. And there are prisms. Cylinder is a special case, and prisms are general classification of group A. So it can be that the name of the prism is derived from the name of its base, or the shape of its base or the top. If the top and base is if the top and base are triangular shape, the prism is also known as a triangular prism. So that is the condition. If the top and base are square, it is the square prism. If it is pentagon, it is pentagonal prism. If it is a hexagon, it is hexagonal prism. So the triangular, square, pentagonal, hexagonal prisms, these solids, they fall in group A. And a special case of a square prism is a cube. A cube is a square prism actually, in which the height is equal to the size of a side of the square. Cube is a square prism in which all the 6 square faces are equal. All the 6 faces are square faces. In a square prism, we have 6 faces, out of which 2 will be squares, 2 opposite. Top and base will be squares, and the other 4 faces will be rectangles in the case of a square prism. But in the case of a cube, all the 6 faces are squares. So that is a cube. So this is a cube. And in the group B, similar to cylinder, there is a cone. A cone is a shape in which the bottom or the base is a circle, and the top is point which is called the apex. So then the pyramids. The pyramids, we have seen the pyramids of Pisa. I mean, Egypt, the pyramids from Egypt. But in that case, most of the pyramids were square pyramids. The base was square. But pyramids in general, may not be, it need not be square pyramids. It can be triangular pyramid, square pyramid, or rectangular pyramid also. But we are basically bothered about the square pyramid or square pyramid, not about the rectangular pyramids. Then there is a pentagonal pyramid and a hexagonal pyramid. In all these cases, the base is either a triangle or a square or a pentagon or a hexagon, and the top, on the top part, there will be only a single point. That particular point is known as the apex, and that apex will be only a point. So that is triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. And a special case of a pyramid is a triangular special pyramid, that is a tetrahedron. In this case, if you see a triangular pyramid, you can see that there will be only 4 faces. One is the base triangle, and the other 3, the base is a triangle, and all the other 3 faces, which are the lateral faces, they are also triangles. If all the 4 triangles are equal, then this 4 triangular faces is known as, or this particular solid is known as tetrahedron. That is, in the case of a tetrahedron, all the 4 triangular faces are equal. All the 4 triangular faces are equilateral triangles. In the case of a triangular pyramid, in the case of a normal triangular pyramid, the base will be normally a equilateral triangle, and the lateral faces or the side faces will be isosceles triangles, in which two sides will be equal and the third side is not equal. But in the case of a tetrahedron, all the 4 triangular faces are equilateral triangles. This is the case. So these are the main types of solids that we will be encountering in our study. There may be some square pyramid, I mean rectangular prisms or rectangular pyramids may also come up, but it is also limited. This cylinder, cone, then triangular prism, triangular pyramid, square prism, square pyramid, pentagonal prism, pentagonal pyramid, hexagonal prism, hexagonal pyramid, then cube and a tetrahedron. These are the say 12 different types of solids that we will encounter in our study. Now, let's see which are the various dimensional parameters or the different terms associated with each of these solids. 2 terms we have already seen. That is, one is the base and the other one is the apex. And in the case of a square prism, square pyramid, cylinder, cone, which are the different terms associated with. So all these shapes are given. The square prism, square pyramid, cylinder, and cone are given. Then, in the case of a square prism, this face is the top, and this space is the rectangular face. There will be 4 rectangular faces, and 1 top will be there. And this longer edge, the longer edge will be an edge which defines the rectangular face. Then, corner of the base. On the base, there will be 4 corners, and the edge of the base. All the edges of the base will be of equal length. That is, in the case of a square prism, all the edges will be of equal length. And this is the base. The base is the face which is opposite to the top. Top and base will be square in the case of a square prism. It will be a triangle in the case of a triangular prism. It will be hexagon in the case of a hexagonal prism. It will be pentagon in the case of a pentagonal prism, etc., etc. That goes on. Then in the case of a square pyramid, the topmost point, the single point, is known as the apex. Then the slant edge is the edge which joins the bottom or the base corner, the corner of the base with the apex. That edge is known as the slant edge. Then this is the base. Base is the square face. and the base edge, or the edge of the base, or corner of the base. So these terms, or these parameters that you should remember, because the questions will be based on this edge of the base, or base, corner of the base, slant edge, apex, etc., etc. And this is a triangular face. In the case of a square pyramid, there will be 4 triangular faces. In the case of cylinder and cone, these are also known as the solids of revolution. These solids can be generated by revolving an axis, or revolving a straight line with respect to around a specific straight line. This straight line is known as the axis, and if we revolve straight line along this particular axis, or sorry, around this particular axis, it will generate a cylinder. That is not why this is known as the solids of revolution. In the case of a cone, the same procedure is applicable, but in the case of cylinder, the line which generates the circular part or circular surface should be parallel to the axis. But in the case of a cone, the incline, it has to be inclined. That is, there will be a point of intersection of the axis as well as the line which revolves around this particular straight line or the axis. And this particular straight line which revolves around the axis is known as a generator. So normally what we consider is, in the case of cylinders or cones, what we consider that this cylinder is the circular surface, or the curved surface of the cylinder consists of a number of generators, actually it consists of infinite number of generators, but for our easiness we consider 8 generators in this cylinder. How these 8 generators are determined, that we will come to later, we will discuss later. And in the case of cone also, we consider 8 generators, at least 8 generators is required. More than 8 generators is also good, that is 12 is a better suggestion, but if you take 12 generators, it will take more time to draw all these 12 generators. That's why we normally go for 8 generators. So these points are known as generators. These are the imaginary lines which generates the curved surface of cylinder or a cone. Then the base is the circular face, and this is the apex. Here this is the base. And once these basic cylinders, these are the regular solids. Until now what we have seen is these are the regular solids. There are irregular solids also. There are some solids in which the axis is not perpendicular to the base. In all these cases that we have seen, the axis of the cylinder, the solid, is always perpendicular to the base or the top. The axis is the imaginary line which joins the centroids of the top as well as the bottom. In the case of a prism, it is an imaginary line. The axis is an imaginary line which joins the centroid of the top as well as the base. In the case of a prism, in the case of a pyramid, it is the imaginary line which joins the apex with the centroid of the base. So in all these cases that we have discussed, the axis is actually perpendicular to the base. There are some solids which are in which the base is not perpendicular to the axis, or the axis is not perpendicular to the base. They are oblique solids. We are not considering those type of solids in our study, so we are omitting it. And then there are 2 other types of solids which can be derived from this the type of solids that we have already discussed. These are the derived solids, or actually these are not derived solids. These are the solids which we can generate from the regular solids, in which case some part of it is removed. So let's see some of them. So these type of shapes, these are known as the truncated solids. That is, the top and the base are not parallel. Actually, in the first case, it is a part of a cone. This is a part of a cone, and some part of the cone is removed. Some part of the cone is removed. So it is a truncated solid, and the top face is not parallel to the bottom face, or the base is not parallel to the top. So that is why this is known as the truncated solid. This is a part of a cylinder. This is the part of a pyramid. There can be a part of a prism also. So when the top is not parallel to the base, then it is known as the truncated solid. Then there is another condition. This is frustum. In the case of a frustum, the top and base are parallel, but it is part of a pyramid or a cone. It cannot be the part of a cylinder, or it cannot be part of a prism, because if we cut a cylinder in such a way that the top and the bottom are parallel to each other, then it becomes a smaller prism or a smaller cone. A smaller cylinder. But in the case of a frustum of a cone or the pyramid, what happens is a pyramid part is removed from the top of this particular pyramid. So, and the bottom part, what is remaining, this is the frustum. So in the case of a frustum, the top is again a square. If it is a square pyramid, then the bottom is always a square. So, but these two squares are of different size. So that is the frustum of a cone. Frustum of a square pyramid. This is the frustum of a cone. In the case of frustum of a cone, both the top and the bottom are circular shapes, but the top circle is of having a lower radius, or a radius which is lower than the bottom radius. So that is the difference. So this is the frustum of a cone, and whatever part that is removed, it constitutes a smaller cone. And here in the case of a pyramid, whatever constitutes the whatever is removed from this particular pyramid, that part is also a smaller cone, smaller pyramid. So that is the frustum. Now let's see how these the views, which are the different types of views that we will encounter. So while observing the front view, the XY that we have already seen, that is, while if you are observing the front view, the front XY line represents the horizontal plane, that we have already discussed in our preliminary classes. So preliminary classes means the starting classes of this engineering graphics itself. So while observing this front view, the XY line represents the horizontal plane. So this is one condition in which the a pyramid, I don't know which pyramid it is. It can be a square pyramid, or a triangular pyramid, or a hexagonal pyramid, whatever pyramid it is. Maybe it is a square pyramid. So we can assume that it is a square pyramid. A square pyramid is standing on HP on its base. So that is the condition. It is standing on HP on its base. So the base is coinciding with the HP. See this face. This side is facing the or coinciding with the HP or XY line itself. Then it shows only a triangle. So this is the front view of a square pyramid. And the axis is perpendicular to HP and parallel to VP. In this case, when a pyramid which is standing on HP means, which is resting on HP on its base, means the axis is perpendicular to HP and parallel to VP. So now this is another case. In this case, the pyramid is resting on HP, but on one of its base edges. So resting on HP on one point of the base circle. So sorry, this is base circle. So it is a cone. It is not a square pyramid. It is a cone. So for a cone as well as a pyramid, the front view will be a triangle itself. So we may not be able to differentiate between a cone and a square pyramid when only the front view is given. So it is a cone. The front view is that of a cone. So one point of the base circle is touching on the XY line, or it is on the HP. So that is the condition in this case. And here also the axis is inclined at an angle to the HP. Now the axis, this is the axis is inclined at an angle to the XY line, or that means with the HP, and the axis is parallel to VP. The axis is inclined to HP and the axis is parallel to VP. That is the second condition. Now another condition, a third condition, in which it is resting on one of its generators, that is on its side faces, or one of its generators it is resting, and it is resting on XY, or I mean on HP on one of its generators. So it is lying on HP on one generator. In this case also, the axis is inclined to HP and is parallel to VP. The axis is inclined to HP and parallel to VP. See, in all these cases, the shape of the front view is the same. If you observe it, the shape of the front view is the same. That is a triangle. The shape of the front view is a triangle in all these three cases. The only difference is that the orientation of that triangle is different. In one case, the base is coinciding with the XY line. The second case, only a corner is coinciding with the XY line, and in the third case, one of the slant edges is coinciding with the XY line. So that is the only difference, but the front view is the same. So if we keep the axis parallel to VP and change the inclination with respect to the HP, the front view doesn't changes. The front view will remain the same. That is the condition. The front view, the shape of the front view will remain the same. So that this property will come into action, or will be useful when we draw the projection of solids. Now let's see the top view. What is the conditions of top view? While observing top view, the XY line actually represents the vertical plane that we know. That is, the XY line is which is representing the vertical plane that we already know. See, this is the top view of, again, a cone. So the top view of a cone is a triangle when it is resting on VP. This condition is when it is standing on VP on its base. In the first case, this case it was standing on HP on its base. So here it is standing on VP on its base, and the axis is now perpendicular to VP and parallel to VP. Here the axis was parallel to VP and perpendicular to HP. Here the reverse is there. That is, it is fixed on the VP. That is, the cone is placed in such a way that it is resting on the VP. So that is the top view. And in the second case, again it is the top view. It is resting on VP on one point of the base circle. The axis is now inclined to VP and parallel to HP. This is the top view. And the third case, it is lying on VP on one of its generators, and the axis is inclined to VP and parallel to HP. See, in all these three top views, the common point is that the axis is parallel to HP, and the axis is parallel to HP. But in first case, the axis is perpendicular to VP. In the second case, the axis is inclined to VP. Third case, the axis is inclined to VP, but it is lying on one of the generators. So if you observe all these three conditions, the top view remains the same as long as its inclination with HP remains the same, or its inclination with HP, or the axis is parallel to HP. So this is the third condition. I mean, this is the next condition that you should remember. That is, keeping the inclination with the HP constant, if we rotate the object with respect to the VP, then the top view remains the same. So the shape of the top view remains the same. In the first case, in the top case, from this case, what we observed is that keeping the inclination with the VP constant, if we rotate the object with respect to HP, the shape of the front view remains the same. In this case, what comes is keeping the inclination with the HP constant, if we rotate with respect to VP, the top view or the shape of the top view remains the same. So these are the two things that you should remember or you should understand when we do the projections of solids. I hope you understood the concepts. Any doubts? Any doubts till now?
No, sir.
Yeah. Okay. If you feel any doubts or anything which you require more clarifications, then just unmute and ask. Okay. Now, actually, the projection of solids problems are normally solved in 3 steps. There will be 3 steps involved. Unlike in our projection of lines, we had only some few steps, or in some cases, the number of steps are large. But in this case, in the case of the projection of solids, there will be only 3 steps. But the difficulty is that the entire thing is dependent on the first step. If the first step is right, then half of your drawing is right. And if the first step is wrong, your entire drawing will be wrong. So that is the importance of the step 1 in the case of projection of solids. So in the step 1, what we consider is that we assume that the solid is standing on a plane with which it is making some inclination. So in the cases, in the problems involving the projection of solids, what it will be given is that the axis is inclined to one of the planes and the axis is inclined to the second plane also. The axis is inclined to both the planes. That is the condition. But the inclination of the axis will be given to, in most of the cases, the inclination of the axis will be given to one of the planes, and the inclination with the second plane will be given indirectly. Not the direct inclination of the axis won't be given. In most of the cases, I am not saying that in all the cases it is the condition, but in most of the cases. In most of the cases, the inclination of the axis with the one plane will be given, and the inclination with the other plane will be given indirectly by giving the inclination of a particular plane of this particular solid, or inclination of a particular edge of this particular solid, etc., etc. So when we see some questions, that you will understand how the questions will come and how you have to tackle all those things. So in the step 1, we assume that the solid is standing on the plane with which it is making inclination. That is, we have only two planes, HP or VP. So both these conditions we have already seen. So we assume that the plane is initially, the solid is initially standing on the plane with which it is making inclination. So if it is inclined to HP, then we assume that it is standing on HP, and we draw the front view as well as the top view. When the object is standing on HP, first we will be drawing is the top view, and when it is standing on VP, what first we will draw is its a front view. Why it is so? Because when the object is standing on VP, the front view will give you the true length. I mean the true shape of the object. The true shape of the base or the true shape of the top will be obtained in the front view when the object is standing in VP. But when the object is standing on HP, the top view will give you the true shape. That is why we always start with the true shape of the section or of the object that we want to draw. Then, if the object is standing on HP, its top view will be of true shape of its base or top. So when the object is standing on HP, its top view will be true shape of its base or its top. So if it is standing on VP, its front view will be of true shape of its base or top. Then begin with this view. That is, begin with the view which gives you the true shape. Then its other view will be a rectangle if the solid is a cylinder or one of the prisms. And if the second view will be a triangle if the solid is a cone or one of the pyramids. So the top view or the front view, one of the views will be the true shape of the base or the top, and the other will be either a rectangle or a triangle depending on whether it is a cylinder or it is a cone, or whether it is a prism or it is a pyramid. So then draw the top view and the front view of that solid in the standing position. So that is the first condition. If you look into all these three conditions, all these four diagrams that is given below, see the first figure in all the four conditions. This is the first figure. Here it is a cone. The group B solid, it is a cone. So in the case of a cone, the top view is a circle and the front view is a triangle. That is, this is when the cone is resting on HP. Here it is a cylinder. A cylinder in this case, the top view is a circle and the front view is a rectangle. So again, it is resting on HP. Here, the first figure, the front view is a circle and the top view is a triangle. The object is resting on VP. Here, the front view is a circle and the top view is a rectangle. So that is, the object is resting on VP. So these are the four different conditions of cone, cylinder, again cone and cylinder, and as well as it is resting on HP and VP. Now, in the step 2, so this is the first step. And in the second step, what we do is we consider the solid's inclination with the plane in which it is resting. We consider the solid's inclination or the position of the axis with respect to the plane in which it is resting. So, and we draw its front view as well as top view. See here in the first figure, if you look, this is a triangle and the front view is also a triangle. And here the inclination of the axis is given. So the front view will be same in both these cases. The shape of the front view will be same. Here the top view changed. Here it was only a circle, but here there is an ellipse as well as some triangular part is, some conical part is also there. So that is the top view here. Here, see, here also in the second figure, if you note, in the second figure, within that second figure, the first part was the initial position, and the second part, it shows the inclination with the HP. See, this is the inclination with HP, and this is rectangle as well as this is in rectangle. The first part is the front view is a rectangle, and the second part also the front view is a rectangle. The only difference is the orientation has changed. In this case, in the first part, it is one edge of the rectangle was coinciding with the XY line, but here only a point is resting on XY line, or a corner of the rectangle is resting on XY line. And the top view, see, the top view has changed. In the first part, it is a circle, but in the second part, it is again an elliptical shape as well as some shape. And in the case of a group B solids, that is cone, when it is resting on VP. The front view is a circle, and the top view. See, the top view in the first two parts is the same. The shape of the top view in the first two parts is the same. Because since it is resting on the VP, the top view, the shape of the top view remains the same. Here the inclination is with respect to the VP. The axis is inclined at an angle to VP. That is why it comes like this. And the front view is similar to the top view that we obtained in the first figure. This top view as well as this front view, this is similar. Then here also, in the last case, the last figure, the top view is remains the same, first part and second part. This is remains the same. So the first figure or the first part, we call it as the initial position. That is the initial. In the case of the initial position, the axis is perpendicular to the plane in which the object is resting. It may be resting on HP, or it may be resting on VP, but the axis is always perpendicular to the plane on which it is resting. So in the case of the first two figures, the axis is perpendicular to the HP, that is in the front view, the axis is perpendicular to the XY line. And in the last two figures, in the top view, the axis is perpendicular to the XY line. That means the axis is perpendicular to the VP. Now, in the third step, the last step, considering the remaining inclination. So one inclination we have already given, and in the third step, what we give is we will consider the remaining inclination. That is the third inclination. We draw its final front view and top view. See, in the first figure, if you see the first figure, this figure, the second top view and the third top view is the same. Second top view and the third top view is the same. The only difference is the orientation. This top view as well as this top view, the orientation is different. And then you have to find out the next front view. Here also, the second top view and the third top view are the same. The only difference is the orientation is different. The orientation with respect to the XY line is different. Then the front view is a different figure. So in the case of the third and fourth figure, the second front view and the third front view are the same. Second front view and the third front view are the same. And the orientation is different. And the last front view is, top view is a different figure than the all the previous figures. Here also the same case. The second front view and the last front view, both are the same. So using these three steps, we draw the projection of lines, projection of projection of solids inclined to both the planes, with its axis inclined to both the planes. So these are the three steps that is required. See, in all the three steps, if you require, we have to draw 6 figures, out of which a pair of them will be equal. Here these two figures will be different, but these two figures are same. Here also these two figures are the same. The only difference is the inclination is different. So you have to draw all these 6 figures in order to solve problems related to projection of solids whose axis is inclined to both the planes. So you have to draw it in your book, considering that you need this much space to draw all these 6 figures when the axis is inclined to both the planes. When it is not inclined to both the planes, then if it is perpendicular, if it is in its symbol position, that is the initial position, or in the symbol position, you have to draw only 2 drawings. When it is inclined to one of the planes, or in the plane in which it is resting, then you need to draw 4 figures, these 4 figures. When it is inclined to, when the axis is inclined to both the planes, then you need to draw all the 6 figures. So considering this in mind, you have to start your drawings.